everybody. Welcome to TOC 513. We're going to talk about the area model. So think back to what we've been talking about the last few days with area and with the factors of area, which are the length times the width. Remember, factors are always terms that multiply to give you a bigger term or expression. All right, so what is the area model? The area model is basically just like rectangles or squares that actually show you what a area is, what the area is and what the factors are. So for example, if I have like 24, right? I know that factors of that are 1 times 24, 2 times 12, what else? 3 times 8, 4 times 6, and 5 doesn't go into it. And I think the next one would be 6 times 4, which I already have right there, so I actually don't even need to write that. So this is the term, right? And these are the factor pairs, right? So if I wanted to use an area model for this, I could say, all right, I've got 1 and 24, so I could make a length of 1, and 24 is a lot longer than 1, right? So I've got a width of 1, a length of 24, and that would give me an area of 24. So again, these two are the factors, and the area would be inside. Now, I could also take other factors of 24. I could say 3 and 8, right? So 8 is bigger than 3, but not so much bigger like 24 is, right? So if I say that this is 3 and this is 8, again, 3 times 8 makes them factors. The area inside is still 24 because 3 times 8 is 24, just like 1 times 24 was also 24. So these two guys have the same area, but they have different factors, or in this case, different lengths of the sides. All right. So even though they're both rectangles, they look a little different. All right. So keep that in mind as we start incorporating variables into this. Oh, and there they are. All right. So first of all, let's complete this area model. So here I've got x times x, so my area would be x squared. Here in this box right here, I've got 5 times x, so it would be 5x, because 5 times x is 5x. All right, down here, 1 times x, let me circle them. 1 times x gives me 1x. And in this box right here, again, I look over to the left and I have 1, and I look up from that box and I have 5. 1 times 5 is just 5. All right, so complete the area model below, check. Now describe what each number, variable, and expression represents in the diagram. So for example, either describe it as a side length or as an area. All right. So let me change colors. All right, so this x is up here. That would be a side length. Remember, oops, I spelled that wrong. Sorry, guys. Remember, if it's on the outside of the rectangle, then it is a factor. It is a side length. Okay, if it's inside of those boxes or rectangles, that is the area. All right, so let's continue. All right, so I'm talking about my side lengths. So I know x is a side length, 5 is a side length. So let me find that, side length. This x right here, all right, is also x, right? That's still a side length. And 1 is also a side length. Again, they are all described like that because they are outside of the box. And those are all factors. Okay, if they are the side length, they're a factor. Now, inside is the area. So here I have x squared. I see x squared. So that is an area. 5x is inside, area. 1x, again, that's inside, area. And 5, area. All right. Now, I've got these two guys right here. Where on earth are they getting x plus 5? Okay, I think I see it. Do you guys see it? So if I look at the top, right, if I want to know the full length, right, from right here, right, to right in the middle, this is 5. And then if I go a little bit more, this is x. So the whole thing is x plus 5. So that would actually, let me put green, that would actually be a side length. But instead of just saying what one of the little sides, like this is x as a side length and this is 5 as a side length, again, x plus 5 is the whole side length. All right, and then the same rationale down here. X plus 1 gives you this entire side length. Side length. All right. Write an expression for the area of the entire large rectangle. So I can do that in two ways. One way I can do that is in my factored form. And remember, factored form are the factors which are the side lengths, right? These are all of my factor parts. So I can say y equals x plus 5 times x plus 1. So I'm taking this entire side length times this entire side length, and that gives me the area, the whole thing. So I'm writing out just those factors. Now, if I want standard form, let me actually do that in red. All right, so standard, let me not do that in red because that is just not showing up. All right, so standard form would be all of the areas added up. All right, so here I've got 1x squared. Remember that 1 can be invisible. And then 5x plus 1x gives me a total of 6x's. And here I've got a positive 5. For some reason it kind of looks like a negative because I put those points there. Let me just try and do that again. All right, so this is a positive 5. So I would have plus 5. All right, so again, factored form and standard form are exactly the same expression. They're just written in two different forms. And before you go to the next slide, remember that your y-intercept is easily seen in your standard form. And your x-intercepts, x is -1 and x is -5. Remember, always the opposite of what you would think. Oops, that does not look like x-intercept, but it should. So here your x-intercepts would be -5. I can't. I'll just write it over here. X equals -5 and x equals -1. Remember, whenever it's inside the parentheses with those x, the x-intercepts is the opposite sign that you would think. Okay, so I'm going to go through these fairly quickly. Again, if you feel like, what is going on? Look on Google Classroom, and we have the links posted in our class stream. Okay, and maybe I'll post them again so you can go to me or Mr. Q and Miss Mock. Either one is fine. All right, so here I look to see for number 1 that I've got 2 factors, right? One is x plus 3, right? That's the length of this side. And the other factor is x plus 2. That's the length of this side. Now, remember, the area is length times width. So when I do x plus 3 times x plus 2, that is the area, right? Length times width is the area. I can also represent it as what's inside the rectangles. So here I've got x times x is x squared. 3 times x, 3x. 2 times x, 2x. And 2 times 3 is 6. All right, so now I'm just going to actually write that in here. And let's see. So I have x squared plus 3x plus 2x plus 6. So that's where I got the numbers. I just added up all of the areas inside. So x squared plus 3x plus 2x plus 6. And I'm putting plus because they're all positive. All right. Now, there's only 3 boxes below because I'm writing x squared. And here I've got like terms. The positive 3x plus 2x. So that gives me a total of 5x. All right. And now I just am going to bring down that plus 6. All right. So again, this is standard form. And up here, what they gave us was factored form, right? The sides. Oh, that should be FF, factored form. All right. So here again, I've got factored form, right? X plus 4 times x plus 3 is the area. So that is one way you could represent this quadratic expression. You could just say x plus 4, x plus 3, right? And the y value represents the area. Okay, so why did I do that? Okay, so in both of these, your y values are the areas. So let's get going. So x times x, x squared. 4 times x, 4x. 3 times x, 3x. And 3 times 4 is 12. All right, so you can just follow along as I write in. Better yet, pause it and see if you can write it in yourself. Okay, so remember I get the 7x because I added 4x plus 3x. Okay, now this, we're just working backwards, all right? So we kind of are learning it frontwards, and then the way you get fluent in anything, in fact, let me take that back. The way you get fluent in math is you can know it forwards and backwards, right? So here, same idea, we're just working on our fluency. All right, so same area method, right? So I know the area method is, the area is length times width. So if I were to do factored form, that is y equals x plus 5 times x plus something, right? I don't know what's in there. All right, so I need to figure that out. All right, so let's go. So I have x times x gives me x squared. Now 5 times x gives me 5x. So now I know what that blank is. All right, so I can put that right here, 5x. All right, so now x times something gives me something. Oh, okay. All right, well, how can I figure that out? All right, so now x times 5, or not x, sorry, a blank times 5 gives me 10. So what number times 5 would give you 10? If you chose the number 2, you would be correct. So here, this blank gets filled in by a 2 because 2 times 5 gives me this 10. All right? So now I know 2 times x gives me 2x. All right? So now I can say, okay, x plus 5, right? That's this side. And then x plus 2. And actually, I already have a 2 kind of in there. But that was just an accident. X plus 2. All right. So now let me finish this bottom part off. So I have x plus 5 times x plus 2 equals, and actually let me make this red. I like making different colors. All right, so I've got factored form over here, and now I'm going to write standard form. So I've got x squared plus 5x plus 2x plus 10. All right, cool. So I can combine my like terms. So that gives me x squared plus 7x. And then I just bring down my plus 10. And this is standard form. All right, so again, both of these guys, right, both factored form and standard form is equal to y. All right, so they're just two different ways of writing the same expression. All right, so we're actually going to go to the next page. I'll let you figure 2 out on your own. And let's go to the reflection. So just quickly, let's look at this. We have x times x gives me x squared. Now we have x times something gives me 5x. So the only term that could be there would be, think about it, 5. X times 5 is the only combination that would give me 5x. All right, so now let's look over here. X times what gives me 1x? Think about it. All right, and your answer is 1. X times 1 is the only thing that would give you 1x. Now, this has got to work for this term also. So let's make sure. I go to the left, 1. I go up times 5. And 1 times 5 is 5. Excellent. Okay? And now if you notice, 1x plus 5x, they've already combined that to 6x for you. So I've got x squared. I've got 5x plus 1x is 6x. And 5 is here. Now I've just got to fill in my factored form. So remember, this is standard form. So on the top, I have x plus 5. And on the side, I have x plus 1. All right, so I got my factored form and my standard form. Let's see what they want. What does the x represent in this diagram? Well, the x, as you can see, is outside. So it is a side length. All right, what are the dimensions, the length and the width of this rectangle? And that means the entire rectangle. So that would be my factored form of x plus 5 is the length, and x plus 1 is the width. All right, what does x squared mean? So x squared is the area of x and x. So it's not the whole area, it's just a part of the area. Now, how do you know if an expression models a side length or an area. So if it's a side length, it is outside. And if it is an area, it is inside the rectangle. All right, and that about does it. So any questions, comments, or concerns, write it down, phone a friend. Remember, get everyone's contact information, call them up, say, hey, you want to edit my essay before I hand it in? You want to talk about quadratics in math class? So talk to each other. Google it, see if you can figure it out. Email me, Mr. Q. All right, we'd love to hear from you. Come to our office hours. Sometimes nobody comes, sometimes a few people come. We want to hear your questions. It's so important to keep up on a daily basis, or else you feel like you're kind of falling behind, and nobody wants that. All right, so you got this. Have an excellent day, and let me know if you need anything from me. All right, see you later.